conditioning kills me. Okay, I'm Dale.Henrichs, and I'm from GemTalk Systems, and I'm going to talk about, for the most part, I'm going to talk about Rowan and a little bit about Jadeite. Rowan is a brand new project and package manager for Smalltalk, intended to be for Smalltalk, and Jadeite is a development client for Rowan and GemStone. So I'll start with Jadeite, and so Jadeite is a Dolphin-based client. Oh wait, I think I lost myself. Okay, yes. I'll stay. Usually I'm jet lagged, and I'm not used to giving a presentation when I'm not jet lagged. I think that's the problem. Unfortunately, slept every night this week. All right, so Rowan and Jadeite are part of the GemTalk's effort to provide real supported development environments for GemTalk, for GemStone. Yeah, it's exciting, isn't it? In the past, we basically relied on our clients, okay, to provide the development environment for GemStone and then use GBS for shipping things back and forth. And so, now is the time with Git and being able to use Git for source code control has really opened up things for GemStone to, realistically create a development environment, saving packages and things. So anyway, so that's what Rowan and Jadeite are all about. And the other piece of this is we actually have a commercial customer that came to us at the beginning of the year, or a little bit before the beginning of the year, and asked us to provide them with a development environment based on Git for GemStone. And so that's what we did. And so they're actually in production right now with Rowan. So it was a quick project, and very interesting in many ways. Okay, so I'm going to talk about Jadeite a little bit. What you've got is Jadeite is kind of, it's a basic, what you're looking at right now is a basic system, because we're kind of starting with scratch. So we're doing browsers, a transcript, and debuggers. And if you notice, we've got projects, if you can see that, projects, packages, and then we go into the classes and categories and methods. So that is a Rowanized version of Jade, and you might recognize this, part of this as derived from Jade, and but we Rowanized Jade for this. And in terms of managing Git, what we have, if you look at the menu item, we have about 4 or 5 different menu items there for doing very basic operations with Git. And so, because Rowan is SCM aware, but this is the awareness part, where you just say save and commit and load. All right, the current Rowan status is we are in production at a GemTalk customer site. It's running on GemStone 3.2.15, and it's not quite feature complete. So today, you'll see some slides with fine print on it that you can't read, but it's the fine print. This is not an implemented feature. So I'll be talking about things that are planned to work. And of course, the deal is our customer didn't need these features, so they fell by the wayside as we moved forward. The current Jadeite status is they're using an alpha version right now for development, and soon they'll have a new version of an alpha to give them. And Jadeite runs on Windows, but can be used on a Mac with Wine. I've tried to use it on Linux, and the Linux version of Wine has frozen on me, so I can't recommend trying it on Linux. Okay, so what Rowan is it is intended as an updated implementation of Monticello and a wholesale replacement for Metacello. If you look at Metacello and Monticello I think is like 15 years old. I think it was first introduced in somewhere 2003, 2004. Metacello was 2009, and so it's 10 years old. And when you go back 10 years ago, the development environment did not include Git, or even acknowledging that there is a disk outside the image. And so, Monticello doesn't really need a complete overhaul, but Metacello does because of the problems that I was trying to solve. So, and I know Metacello, so I can kick it all I want. Talk about how, what the problems with it. So, with Rowan, there's a new structure. In Monticello, the structure in your image basically stops at the package level, and there is no other structure above the package. I see Pharaoh 7.0 that the projects have been introduced, which are based on basically a Monticello mapping, I assume, and a Metacello mapping. And but for Rowan, the evolution has gone to where you have a project made up of a set of configurations. And a configuration points to other configurations and external project references. And then you have, then the configurations also point to packages. And the packages have classes and methods, familiar to the Monticello folks. And then class extensions and methods. So the configurations, I think, is the new feature. And it's the new feature that's replacing Metacello. So in the image, a Rowan project is named. It's associated with a set of directories on disk. And as I say, it was SCM neutral and git aware. So a project is working with a path to a particular repository at the moment. And loading is performed using a project load specification, not a Metacello load expression. Let's see, so I'll talk about the load specification. It's named, and it specifies a disk structure for the project. The source directory is equivalent to the repository or source directory where the packages are stored. And then there's other elements for Rowan are configurations and specs, and those are in separate directories. And the specification also specifies load parameters for a list of configuration names and group names and some repository specifics. The declaration is instance-based, and if you look at Metacello, one of the issues with Metacello is it's actually a package and a class. And that means that in order to get anything out of Metacello, you have to execute Smalltalk code. And from the security perspective, you have to execute Smalltalk code to just look at what's inside the baseline, which means any Smalltalk code can get executed when you do that. But for what I've done with Rowan is go to instance-based and using stan to store objects on disk. And so what you're storing for a project specification is an instance of a project specification. That gives us a lot of flexibility where we can have multiple implementations, multiple class representations for a project spec, and even support future expansion. A project spec is meant to be located anywhere. It can be on disk, HTTPS, or wherever, and it's meant to be customized by the users, because this is basically the moral equivalent of your Metacello load expression, which is always being customized by someone. And this allows you to decide what customization you want and put it on disk. It's objects. You can now merge and manipulate objects if you want to, and maintain and generate them programmatically in an image, and then dump them to disk. And so this is a picture of a project load specification. I'm not going to go into detail here because I'll talk more in detail later in the presentation. Now I'll talk about Rowan configurations. They're named, and unlike Metacello, the configuration is the minimum loadable unit for Rowan. So in Metacello, you can load packages. And what's always driven me kind of crazy about the fact that something like Seaside with, is there 100 packages? A couple hundred? Something, yeah. A very large number. Who knows whether if you load an arbitrary package in Seaside that it'll actually do what you think it's going to do. And oh, by the way, what do you think it's going to do? So the notion of having the minimal loadable unit be a configuration is that you can now specify a chunk of functionality, could be a subsystem, that is made up of this set of packages, and that's what you load. And I expect them to define a loadable system, and I expect them to include the core and tests and examples, all right? And these would be declared as groups, and we'll get into that a little bit more. Let's see. The other thing that Rowan has is sorry. The configurations can be nested, and actually there's a whole, I think I've got 4 or 5 different classes implementing configurations at the moment, and configurations can be recursive, all right? So in Metacello, one of the things that is a classic problem is ending up with a dependency loop that Metacello can't solve. And rather than try to solve the problem, I decided you can recurse. And I think it's not a bad model. If you think about a class method or a method in a class, it can reference every class in the system, can't it? And it will work perfectly correctly. All right. So, and yet, what would the dependency look like for one of those methods? Anyway, you go crazy. And configurations are instance-based declarative, stored as stone, and same thing. We can support future expansion. The other thing that's useful is because it's an object, you can load that object and do analysis independent of Rowan and of what would be going on. And then this is an example of the simplest configuration. It's a list of packages. It's named and has a list of packages. So for folks that have one package and saying, why do I have a package, or one package in their project, why do I have a package and a class that has more stuff in it than the class that I'm actually loading? Well, this is part of the rationale for configurations. One of the other features of Metacello is external project references, and again, they're objects, they're named, they reference a project load specification URL. So it mirrors what you would do if you had written a Smalltalk expression to do the load of a particular project. And it's a kind of configuration, all right? And so it is inserted in the configuration network and treated, resolved as just another object that we ran across. And oh, by the way, it references this other project that needs to be made, may or may not need to be cloned, resolves additional projects, packages. And one of the features of Rowan is that it doesn't just load packages, it loads projects, and it loads a set of projects. So if you think about the whole network and possibly recursive network of dependencies that you might pull in, at the end of the day, you'll have a set of projects that need to be loaded with a particular packages for each one of those projects, and then we do the job. And this is a picture, so I do want to mention that line that you can't read at the bottom and maybe you can't even see, that's the fine print. So I haven't implemented external projects yet, so I'm talking about stuff that will probably show, well, something like this will show up. Maybe not exactly this. And I'll talk more about external projects as well. All right, so I want to give you an introduction to kind of the overview of Rowan, and now I want to get in a little deeper into just what's going on. And so updating Metacello, or Monticello. So Monticello, or Rowan, like Monticello, is definition-based. There's a package reader-writer, and it supports Tonel and FileTree. And there's a set of definitions that, for Rowan, have been expanded to include package definitions and project definitions, and possibly configuration definitions. I say possibly because configurations exist right now as a helper for the loader, for the Rowan loader, but I really think that they need to be represented in the image. And so that project browser I showed you earlier that had projects and packages, there really needs to be a hierarchical list of configurations in there as well. Because configurations can be used to not only define subsystems, but they'll just help you. If you've got 700 packages, give you some more organization besides a naming convention in a category. The second part of this is Rowan has first-class objects for all of the loaded things. And the loaded things are projects, packages, and classes and methods. And the loaded things are directly updated by the project loader, and I think I mentioned that earlier, that it's a project loader, not a package loader. And every class and method knows exactly where it came from, and without having to do a lookup. And that was extremely important for the GemStone implementation because we have customers with hundreds, maybe thousands of classes in their system, and it would be prohibitive.
10,000 at least.
Okay, 10,000. So they meant 10,000. So this was a requirement. And so what I've got here is an example of some Smalltalk code that creates, and this is actually stuff for the Monticello nerds. Are there Monticello nerds out there? There's a couple of you guys out there that have tried to work with Monticello and build things. This is for the Monticello nerd because you create a project with a nice creation protocol. I'll do some more of the definition-based stuff soon, but at the bottom, that's how you load. This is the fundamental load operation for Rowan. You load a project definition. You can also load a set, but at the bottom you're dealing with project definition. And there's a clear API for doing it. So for class and method creation, you can create a class definition and then add instance methods to that. And you notice the method, it's add instance method or add class method are the protocol that's being used. And the method doesn't necessarily have to know whether it's on the class side or instance side. We'll just simplify things for dealing with the definitions. And then project definition, you access a package and add a class definition. This is, if you've worked with Monticello, you would know why I'm showing this. And same thing for class extensions. So there's a class extension definition that you can create, add methods to that, and then add the extension to the package, and then load. So generating, I've got the test system has evolved to just generating all the test cases in line in a method, and generate the project definition and do the variety of loads that are needed. Okay, so replacement for Metacello. This is what I'll do is go through and try to compare what you do with Metacello with what you would do with Rowan. So the first place we'll start is the first box contains a Metacello load expression, and that may be familiar to you. And the second box is showing you how you load using Metacello. And so all of the information that is in the Metacello Smalltalk expression is encoded in the project specification, which is what that URL is. And I give you an example of a file URL and an HTTPS URL for accessing a spec from a GitHub. Now I'll show you some of the details. So the highlighted items are what pieces of information do you throw into a Metacello load expression, and where do they show up in a project specification. So we basically don't lose any information. You've got the name of the spec, you've got the location on GitHub where to find the project, and you also have the commit that you want to use, or the commit-ish that you want to use. It's got the repo path, which is, in my case, Rowan source, and it gives you a set of default names that you would use to load the project. And that all maps to exactly what you would use with the Smalltalk expression. Now, and there's other stuff, all right? And that's, so there's interesting things that can be done there. And we'll go on to the next. One of them is there's 3 different types of information that's associated with the Rowan project. You've got the source code, and then you've got, and that's the repo path, and then you've got configurations. And configurations, if you think about it, you can have a large number of configurations that you're working with. And then you've got the specs path. And multiple specs allow you to talk about multiple supported configurations that you expect other people to use. And there's a default configuration name and a default group name in here as well. And that basically says if you don't specify it on the load expression, this is what will be loaded. So now for doing configurations, what I've got here is an example of a simple baseline of with 3 packages: a core, extensions, and a test package. And 2 groups, core and test. And we'll walk through what that looks like in a configuration. So this is a different implementation or a different class that supports groups and also the conditional platform conditional form of a Metacello spec. So you have the conditional common. So common is the conditional. That can be a platform name, a platform version, very similar to what goes on in Metacello. And then you specify a group name, and then you have package names within the group. And so there's our core and tests. I talked about nesting configurations, so this is an example of the same package structure in 3 different files. And those 3 individual files are individually loadable, so if you want to load tests, you'll load the test configuration. If you wanted to load the core, you would load the core configuration. And then the common configuration would be your default, or what you expect people to use by default. Now you notice I've got in red, all right, so I mentioned before that configurations can reference other configurations. And so that's what's going on there, is you can stick configuration names in there. So the core at the top, the core configuration, loads actually up the, I think I did that wrong, didn't I? No, well, I did define that wrong. Sorry about the jet lag. That should have said just the core package, the core group instead of test at the top, and then tests was referencing core and tests. So anyway, I won't be able to fix that for you, but basically, I think you get the idea of what I'm trying to do. And of course, if you have a lot of packages and a lot of structure, you would do it in this form. So the Jadeite plans, the Rowan and Jadeite plans, so we have some near-term plans, because this last year has been very focused on getting our customer taken care of, and not a lot of time to think, not a lot of time to put in the features that would be needed for other people. So we have some near-term plans to just keep our production customer happy, start implementing some of the missing features that we've passed on because of time constraints. And I've started a project doing Rowan support in Smalltalk CI, and I want to get file system and parts of Zinc ported so that I can do HTTPS and a better file manipulation within Rowan. And also port Rowan to 3.4. So we're on 3.2.15, which is not the latest version of GemStone, but that's the version our customer is using. And the longer term things for Jadeite plans is to port Rowan to GemStone 3.5, which is currently in development, and package the kernel classes, so actually use Rowan as part of GemStone, and that will go on 3.5, 3.6 timeframe. We have plans to create a Pharaoh GUI that uses the same set of services that we created for Jadeite, the Dolphin version. And then integrate Rowan with Toad, Glass, GSDevKit, and GSDevKit Home so that the folks that are currently using GemStone and packages will have a path for converting to Rowan or continuing to use. Because I think Rowan and Monticello and Metacello can coexist in an image. And the entire image does not have to be packaged in Rowan to be functional. That's the way our customer is working right now. And then review and refactor for dialect portability. So, that's my talk. I don't know how long it took. I've got a record now of going shorter and shorter. But, any questions? Yes?
Just to clarify, maybe I missed some of it, but
Yeah.
you said that it was instance-based. You meant that in opposition to the package coming in with a class that represents itself?
In relation to the baseline, which is a package and a class for Metacello. And, the technology for doing that didn't exist in 2009. I don't think Stone came around for a couple of years. So, and of course, in Monticello, you couldn't store non-packaged data, so that was kind of forced upon, that was one of the design constraints. So, any other questions? All right, thank you very much.